Hello everybody, this is going to be a quick demo on how to make sense of JUnit test output. And so let's just get started. First of all, when you start up in IntelliJ, you'll see this sort of search everywhere is a nice one. They have like other more specific ones, but you can always just double tap shift. In this case, I'm going to type sphere because that's the class we're going to build. We can see it's marked as immutable, so we want to make it so that it never changes its state. And we have a constructor that takes a radius. We're going to return sort of a getter for that radius. I used to type get radius all the time. I've sort of, as I've gotten older, started to just return radius or drop the get everywhere. I'm going to calculate the surface area, and I've added this bonus private method called square, which we're going to use when we calculate the surface area. And so always there'll be a test suite. So one of the things I can do is just type test suite up here, and it will spell it correctly. It'll show me all the test suites I have. I can do underscore sphere test suite. I can just type sphere test suite. It'll bring me here. You can see I've a test suite is just a way, and it has a nice way to order which tests are run in which order. And so I'm going to check that the radius is working, that square is working, then this bonus one, which just checks to see if surface area is working, or excuse me, if surface area, if you've created any tasks that they've been joined, then check for the correctness of surface area, and then check that the parallelism that we want in surface area is there. And so if I run this, first of all, you can, while I'm in this file, anytime you want to find out where it is in this, you can like sort of hunt this directory structure, or you can just click on this button, and it'll take you exactly where it is. You can now see all the tests are just hanging out right next to this test suite. If I run this, I can either right click on it and run. You can see it says Control Shift F10 on Linux and Windows. I'm pretty sure it's Control Shift R on the Mac. But if I run that, we'll quickly see that it fails everything, which makes, you'll see this a lot. When I click on this, you can see not yet implemented. All the different instances of this, throw this exact same one. I can click on any one of them. You can see one exception because there's one test in here that it's throwing this not yet implemented exception. The stack trace that it provides you, which is really useful, is like, well, we started out here in this radius test, and then we called sphere, and it threw an exception not yet implemented. I can click on this link. It shows me what line in the test was going. You can sort of see the context of what we're testing here. Here I'm just trying to create a sphere with a particular radius. And that, if I click on that, I can either click on the top of the stack trace, or if I go back to this test, I can control click into a sphere itself, and here I am. Well, I'm supposed to, this is a constructor, I'm past the radius. Let's hang on to the data. Since it's supposed to be immutable, let's declare that it's one field. I'm just going to hold its radius as a final. That means it'll never be reassigned once it is assigned. Nicely, when you make things final, it alerts you that it has not been assigned, which allows us to realize we should declare it in here and assign it to be whatever the parameter that has been passed into the constructor. I can run this again. First of all, now that I've run it, you can see over here in the run configurations, we have only one. I can press this play button, it'll run it again. I'm still going to fail everything, but I will be a little further along. If I come in here, I'm pretty sure I can click this, which will expand all of them. You can see it's now throwing an exception here in radius. I can go back to the test. You can see it's past this line. Now when we're calling this getter, it's failing. Let's just return radius. Now I could say this radius here to access the field because I needed to do it up here in the constructor because the parameter was shadowing the instance variable or field or whatever you want to call it up here. This will pass all of the radius tests. Just by doing it that way. I could also drop this because there is no variable or parameter that's shadowing it, so I can build it that way. So I'm pretty happy with that. Now the test suite is sort of guiding you through to say like, well, let's build the square test next. Now, surface area is going to use the radius. It's going to call squared. It's going to do 4 pi r squared. And a lot of times I'll sort of encourage you to build this little bonus helper method. I will then test it to make sure it's working so that, you know, when you're trying to debug surface area, you can know, oh, by the way, I screwed up square. That's a little bit of a contrived example, but let's go in and check this out. Now I passed all these values in. All of them are failing. You can see that the stack trace is a little more interesting here. We have this invocation target exception at the top, and not yet implemented is down here below. If I expand this up, it's you can see there's a long stack trace between your code And this guy, IntelliJ does a pretty good job of hiding the stuff that is outside of your code. And so you can see just the details here. The reason why we had to do this is if we go back to Sphere, you'll note that I made this square private. In general, you can't, when you make something private, you can't call it from outside of that test. And it's not a good idea to subvert the access system. If there ever is you can via reflection, which I've done here. And so when an exception gets thrown, like this not yet implemented exception, when you call it via reflection, you'll get this invocation target exception, and then the actual cause of it, which is this not yet implemented on Square. And again, I do this sometimes in tests just to, they're appropriately private. I want to test them anyways. If there's ever an excuse to set accessible, perhaps testing a method is a good one. And so let's just go ahead and fix this. Let's imagine, well, first of all, let's not throw an exception. Let's return x plus x. That is, of course, not the square, but let's see what happens when we run that. And so when I run this, you'll see that we no longer have red exclamation points here. We have these yellow X's. And what this is showing that, well, first of all, radius is completely passing. Sphere is passing 0. What do you know? 0 plus 0 is the same as 0 times 0. But 1 and 3 and 4 and all the other ones are failing, except, of course, 2, which 2 plus 2 happens to work. Don't just take it as negative as it's broken somewhere. Like a lot of times these are clues as to what's going wrong. You sort of click on them, the different test case, and see where they're going. This one is expecting 9, got 6. We can go to the spot, and you can see that, well, it called square via reflection in this case, got the actual value back, check to see if they were the same. They weren't the same. Sometimes you'll see this delta on a floating point or double comparison. It's sort of, sometimes there's rounding error or floating point error. And so a lot of times these assert equals want to be like, well, is it really, really close? This one is not close because these things are not the same number. Certainly people would agree 8 is not really close to 16. Certainly not for these purposes. So let's go ahead and fix this. So back to Sphere's square. Let's do times, and we can see it start to pass all those tests. All right, now we're good past square. Now, what's happening now is that the first test that's going to fail is this square area. So that's, we're trying to, surface area. All 4 tests are joined. And the test itself fails up here in this superclass. So abstract bookkeeping test is just trying to make sure that the code that you've run, if it started any tasks, it completed them all. Now, when it went to go run it, it threw an exception. So a lot of times you'll end up in this superclass. It's a little confusing to figure out what's going on. You can always right click on this and jump to the source. And here you can see we're extending that bookkeeping test. And the code to be run to be tested, you can see I'm creating a sphere and I'm just calling surface area. I'm not even checking the return value. All I'm trying to do is say, run this code. And then when it's all done, it's going to say, oh, by the way, here's a chronicle or sort of the bookkeeping of, all the tasks that were created and joined. And all I'm doing is checking to make sure that fork task is equal to the, like every task you created got joined. Now, it's throwing an exception right here before we even get going. Like surface area is exploding first time, but just a little bit, I wanted to show you, a little bit of how to navigate the tests when a test comes up early and you're like, what's going on here? And it's one of these bookkeeping tests. In this case, we're not computing the surface area at all. We're not doing anything. Let's just compute the surface area really quickly. So return 4 times math.py. times, and we'll call our square function because we might as well since we built it. Let's use it. I'm going to hit Control-Alt-L to format your code there and make it all look good. And there we go. We passed all these tests. While we were building this, let's just screw this up and call 8 and do the wrong surface area. You can see now all the tasks that we've created have joined. We haven't created any, so that makes sense. But all of these guys, again, 0 works. What do you know? 0 times things tends to make a lot of things work. See, we're sort of off by a factor of 2 here. Let's imagine we look up our friend surface area of a circle on our favorite search engine. We discover the right one. And now we have this code working this way. So what you can find now is that we're passing everything except for this parallelism test. I look in here again, it's one of these bookkeeping tests that's sort of tracking what tasks are created and what tasks are joined. I can again right click on this, jump to source. And I can see the code I'm testing here is once again just calling surface area on a sphere I create. And now I'm saying, well, did the total forked task count equal 1 or 2? So I want you to imagine we're going to do the square in a task and then compute 4 times pi in the other one. And then join them together and work on it. This one I'm just checking to make sure that you've created the right number of tasks. Let's go ahead and call surface area here. And if I were to do this, let's make a future of type double. And we'll call this the radius squared future. And that is going to equal fork, fork of some task. And let's make a lambda here. And what we're going to do is we're going to return radius. Oh, let's call square. We did it. Square of radius. Okay. And then I'm going to compute 4 times math.pi. So let's just say like double pi 4 equals 4 times math.pi. I've got it right here. Imagine that was a lot of work. It isn't, but imagine that was worth making a task. Then I'm going to come up with radius squared equals, let's assign this to a double, equals radius squared future dot get, let's just call join on it. So I got to call join on this guy. On the future, that'll give me back the value. And now what I want to do is return pi times 4 times radius squared. And so when I run this now, absolutely everything will work, which is nice. I like that. You can imagine, again, let's say, for example, I returned just radius up here. Everything's going to fail. We've gone back now. The parallelism is working because I've got the right number of tasks, but now my tests are off and I can sort of fix that. What I want you to imagine, a bonus one, just let's get it back to working real quickly. This is the correct implementation, or the one that we wanted. Imagine just for a moment that, let's say we just let's say we're going to throw a new null pointer exception here. I could either do that explicitly, or I could, chase null or whatever. Just to sort of show off what happens here is this, again, is going to have one of these problems where it's having an exception. It's not coming up as straightforward as there's a little bit extra complication. So let's say I do this here, right? If I throw the exception here, and let's just look at surface area test, just to sort of see a real quick one. There's just this very straightforward null pointer exception, right? If I throw it inside of a future, let's say, and let's comment all this stuff back in, and let's just not return the correct value. Let's go ahead and throw the null pointer exception right there. And again, I'm going to look at just one of the surface area tests here. You can see there's, again, a little bit of extra information here, right? And there's a lot of details in here, trust me. Of the full stack trace, again, IntelliJ is doing a good job here of eliminating down just to our normal ones. What you're getting here is a Java util concurrent execution exception. That's an exception is thrown to one of the tasks that we've perhaps handed off to a different processor. And so you're getting this indirection where you can see the execution exception up here. You'll sometimes see you can sort of tunnel into the exact, where your code or where the cause of this exception further down. So just sort of look down, find your bit of code, and there we are. And so I'm going to pull that out, build the correct version, and we will be all happy. Let's run it and get it all to work. We love the all green. Hopefully this will help. You'll certainly face a lot of these kind of issues throughout the semester as you're charged with building some parallel and concurrent programs.